us a little bit about what it's like to go through flight training as a high school student. And that talk will be on Thursday of next week at 7 p.m. We have another talk, another engineer joining us, and that will be Mark Vanbergen, who will be joining us on May the 20th. Tell us a little bit about what's involved with being an engineer, designing and building aircraft, and in his case, working on personal air mobility devices. And again, that'll be coming up on May 20th. Well, joining us tonight, we have Jake Stone. Jake is a local product of our aviation education community. He actually lived locally, went to school at Cal Poly San Luis Obispo studying engineering, worked for several years both as a volunteer and as a staff member at the Hiller Aviation Museum, and is currently working as an engineer for Lockheed Martin. He's coming to us tonight from Kennesaw, Georgia. He works in Marietta. I'd like to ask you to join me in welcoming Jake Stone. Go ahead, Jake.
Hi there, everyone. Thank you for having me, John. My name is Jake Stone, and I'm going to be telling you a little bit about how I got to doing what I'm doing right now and a little bit about what that actually is. So with that said, I'll get started. So as John said, I grew up in the Bay Area. I grew up in Foster City and went to Hillsdale High School. And then after finishing high school, I started college at Cal Poly San Luis Obispo. What you're seeing on screen right now, this is our educational flight range on campus. This is where we did a lot of testing for some of the remote control airplanes that I worked on while I was at school. And that was actually a really big part of my time at school there. So I'll be talking about that a bit too. So this airplane here is a flying wing that I helped design. This was for a competition called Design, Build, Fly. I was really interested in doing this competition because I've always really liked working with airplanes and building small airplanes and stuff like that. For this year's competition, we had to build a small airplane that could fit inside a bigger airplane, and this is the bigger airplane. So I really enjoyed flying that. While I was at school, I did a lot of studying, including working with a wind tunnel. This is a wind tunnel test that I worked in. This is a folding propeller, and we were testing how efficient it is. This is the low-speed wind tunnel at Cal Poly. It can go up to 120 miles an hour. One of the things that I really enjoyed about doing this wind tunnel analysis was figuring out what exactly we needed to test and why we needed to test that, and how to improve on our designs. A few other things I did while I was in school. This is another RC plane I worked on for Design, Build, Fly. It's kind of hard to tell in this picture, but this airplane can actually fold up and fit inside of a little tube. You can see the tails fold down there. So this is what we were testing that folding propeller for. So during this time when I was at Cal Poly, I was doing a lot of work studying aerospace engineering and figuring out how exactly to design an airplane. So I got experience in this club, Design, Build, Fly, for several years while I was going through school, and that included getting to go out to competition. This photo was taken in Tucson, Arizona with our plane, and we were there competing with, I believe that year it was 108 other schools, and I had a lot of fun doing that.
How did you do, Jake? Where'd you place?
So in this specific year, we placed 9th overall out of, I think it was 94 teams wound up actually flying at competition. And yeah, we were pretty happy with 9th overall. We had one last flight right at the end of the competition period, where if we had been able to just fly one more lap and land it, we would have placed 4th. But we had crashed our plane several times at that point, and we had some repairs in there, so the balance wasn't quite as good as it was to start with, and we wound up losing it in a turn. And that's too bad.
Now, I'm curious. I've got to ask. You mentioned that this model aircraft that you designed had to be deployed from another aircraft, had to be folded up and come out of a tube. Did you actually have to have the deployment as part of your flights in the competition, or you just fly the aircraft in deployed mode?
So we just fly the aircraft in deployed mode. This was actually from 2 different competition years. The smaller aircraft from the first year, I didn't show here mainly because it didn't really fly very well. But this one, we fit it in a tube. It's actually the tube being held by the gentleman front row, second from the left.
Got it.
So the way we did that is there are 3D printed parts on the wings of this airplane that allow the wings to fold back, sort of like the old World War II Grumman aircraft carrier airplanes. Yeah, and then the V-tail folds down parallel with the fuselage. And this airplane carries hockey pucks.
Outstanding.
Yeah, and then there's also a carbon fiber rod that goes through those wings to hold it all in place. So while I was at Cal Poly, my final project there was to design or go through the conceptual design of a unmanned aerial vehicle, a UAV, for Arctic patrol. And this is the aircraft design we came up with. The full version would be a little bit bigger than this one with the water bottle for scale. So our challenge was that there aren't very many air bases up in the high Arctic that you can use to operate a plane of this size. It would have been about an 80-foot wingspan. So we went with 2 engines so that if we lost an engine, we would be able to keep on operating. Our goal was to patrol for illegal fishing and mineral extraction.
Aeronautical question, Jake.
Yes.
This aircraft is designed for long endurance, right?
Yes.
I'm a little surprised you didn't integrate winglets into it. Was there a process you went through to figure out whether or not winglets would be beneficial on the wing shape?
So we did a mild process in terms of winglets. So what winglets do is they extend the effective wingspan of your airplane and help mitigate the vortexes out on the wingtips. But when your wingtips are as far out as they are on this airplane, our aspect ratio is right around 15, meaning the wing is about 15 times longer in wingspan than it is from front to back in chord. When you have an aspect ratio this high, the benefits of having winglets are actually outweighed a bit by the cost of the extra weight provided by the winglets.
Interesting.
Yeah, that's why on a lot of really long wing airplanes like the Global Hawks or the U-2s, you don't see winglets on a lot of them.
Good point.
Okay, so that was my senior project. Now to talk a little bit about what I am currently working on out here in Marietta. Oh, I forgot what I was working on before I moved to Marietta. So as John said, I worked at the Hiller Aviation Museum for 7 years. My first 2 years there were as a teen volunteer, and I enjoyed it so much that I stayed on and kept working there through all of college and also through the summer and a little bit of the fall after college. And I can tell looking at this picture, I don't remember this being taken, but it was a Wednesday because we wore Hawaiian shirts on Wednesdays when we had Happy Birds in.
That's right.
Yep. So I really enjoyed working there, and I did that for, like I said, a little over 7 years until I got hired by Lockheed Martin here in Marietta, Georgia. And that's when I started my career of keeping big airplanes flying. This airplane is a C-5 Galaxy. It is the largest airplane in the U.S. Air Force arsenal and is able to take off with a maximum weight of about 860,000 pounds. So,
how does that compare to a commercial transport like a 747 or an Airbus A380?
So that's a good question. It's comparable in size to a 747. The original 747 was actually designed for the same contract as the C-5, the very large airlift contract back in the 1960s. The C-5 wound up winning that contract, but the 747 kept on its ability to load cargo by lifting its nose, which is why it's got the hump. So it's very similar in size to a 747. Okay, you can see it also has a lot of landing gear on it. What I was doing when I was working on this airplane was I was a loads engineer. So every time the plane bounced in turbulence, I would look at those bounces and see what that did to the overall airframe. Okay, but since then I've moved on to new projects. I'm currently working on the C-130. This is a C-130J. So I'm a reliability engineer right now. So What that means is I am looking at reports we get from customers where if a part stops working, we make sure there's a repair for it, and we catalog why it stopped working. And if we see a lot of parts come back with the same problem, we'll go in and look for a fix for that. Most of these problems are not essential to aircraft operation, but it's just if the customer has to take it down to fix the air conditioning unit, that means the airplane can't fly for a little while. So we're trying to improve the reliability of the aircraft as much as possible.
You mentioned customers. I'm not used to thinking of big military aircraft and the contractors as it's a customer. Would that be like Army, Navy, Air Force, Marines, or would that be like the Royal Jordanian Air Force versus the U.S. Marine Corps, or who actually is the customer that you're working with on this?
So a little bit of both. So here, when we talk about U.S. government customers for C-130, we're talking about Marine Corps, Navy, Air Force, and Coast Guard. But then we also work with foreign governments through various foreign military sales. So France recently got their first C-130Js operational, and the RAF, the Royal Air Force in Britain, in the UK, as well as the Royal Australian and Canadian Air Forces also have C-130Js operational. The one that always confuses me is Republic of Kuwait Kuwait has them, and they're the Royal Kuwaiti Air Force, and the Republic of Korea also has them. So they have the same acronyms, and I always get confused whenever I see RKAF figuring out which one that is.
I've got to ask, since you have so many different operators flying the same type of airplane, if you get data from, say, the U.S. Marines, and it shows that there's a particular technical improvement that can be made, is that something that you communicate to all operators, or is that something that just the Marines get to share, or just U.S. government operators get to share? How does that work in the military realm?
That's a good question. That sort of varies on a customer-to-customer basis. So we have sold these airplanes to foreign governments with U.S. government authorization, and depending on the actual contract structures and the nature of the changes, sometimes they automatically get incorporated for other customers, and sometimes they get withheld. Obviously, a safety essential item would be spread through other customers, but the air conditioning could be slightly more efficient. Improvement may not be. Okay, and I have just one last picture here to show, which is, this is an LM100J. This is the commercial variant of our C-130s. Now, when I showed this picture originally, I got a question of if this airplane is actually upside down, or if I've just flipped the picture upside down. Now, this airplane is mostly upside down. It's about 155 degrees upside down. So they rolled a little bit before pulling into this loop to give the appearance of being completely inverted while not being fully inverted.
Jake, how many commercial operators are there for an airplane like this? It seems so specialized. It wouldn't seem like there would be a big commercial market for it.
So it is fairly specialized. We do have a few operators so far of the LM100J, and of the previous generation L100s, we did sell, I believe, 120 of them to commercial customers. They're good when you're trying to transport a lot of cargo and don't have much runway to do it.
Jay, I know that some of the other pictures that you showed when we were putting the presentation together, you showed C-130s being used for fire suppression and things like that. Are there other unusual missions the C-130 might be used for, either for a civil operator or a military operator, besides just carrying troops and cargo from place to place?
So the firefighting is a big one. There's several operators that do firefighting with C-130s. They were down in Australia for the bushfires at the start of this year. C-130s are also used for transporting material to the Antarctic bases. So the way a lot of the Antarctic transport works is they'll fly C-17s and other fairly large cargo planes into places like McMurdo Station, which is a big airfield. But then to get cargo out to the smaller facilities around Antarctica, they'll use a special C-130 variant that we call a Snowbird, which has skis and it has slightly different engines for use at the high altitudes.
All right, very good. That's amazing. Well, Jake, we thank you for showing all these pictures and telling us a little bit about what you've done so far. You go ahead and exit out of screen share so we can see more of the folks who are out there. There we go. So, and again, thank you for joining us tonight for our Hangar Talk. I have just a couple of questions before we open up a general Q&A. I'm curious, now granted, I've been along ever since you started volunteering with us at Aviation Camp, but you know, presumably you liked airplanes by the time you decided to come to the museum as a volunteer. When did you first gain an interest in aviation?
That's a good question. I have actually always been fairly interested in aviation. I remember when I was 6 or 7 years old, it must have been, I wanted my parents to read me Around the World in 80 Days because I thought they'd take an airplane, which obviously you could do that faster if they had. But I've always had at least some interest in aviation. I remember when I was going into high school in 9th grade, I went to an air show at Edwards Air Force Base. And it was back when they were doing that air show on a every other year basis, and it was their first one in a while. So there were something like 250,000 people going on that 2-lane road out there. So it took a while to get there, but I saw the F-22 fly, and it did some impressive maneuvers, and then seeing the B-2 fly by out there, it was a really incredible show, and I knew I wanted to do something related to aviation at that time. I was pretty sure I didn't want to be a pilot, but I was thinking if I wanted to do what I wound up doing for 7 years and work at a museum or go into engineering. And then as I went through high school, I realized I'm pretty good at math and science, and I decided to go into aeronautical engineering.
All right, cool. Now you mentioned high school, going through high school and into college. I noticed we've got some kids in our audience today. What things that you learned, and they don't necessarily have to be courses, but what things did you learn in either high school or college that you found to be most useful to you in your career as an engineer?
That's a good question. So first of all, obviously the math and science curriculum is very important to studying engineering. But for me, a big thing was just being able to sort of think on my feet and think through problems as I go through them. One hobby that I had in high school and college, and actually a little bit now still, is I was a quiz bowl player, a trivia competition. And the way the questions in that work are they're really long questions that give you time to think about what they're asking. And just being able to work through that really quickly in a few seconds really helped my lateral thinking skills for going into engineering. Then obviously when I was in college and went through my actual aeronautical engineering curriculum, I still use a lot of that stuff today, even if I'm not directly applying, say, what I learned in my aerodynamics classes. Because of the nature of my work now, I still have that background so that if I need to look at something that is an aerodynamics problem, I may have to go back and refresh myself on the actual math of it, but I have an understanding of what's going on.
Understood. I'm actually going to go off on a slight tangent here. I'm thinking on your college projects working on those model aircraft, and the ones that you're working on now, they're a whole lot bigger. But I remember my brother is also an engineer. He works for Boeing up in Washington State, and I'm thinking now he also did model aircraft work as part of his coursework. He had to design a landing gear system for a remote control glider. How well does working on a small scale aircraft that has a wingspan of 5 feet or less, how well does that really translate to being in the real world working with an 800,000 pound C5?
Oh, it translates really well. One thing is, yeah, it translates really well. All it really is changing your units and changing your scales and changing your materials. For example, the airplanes that I showed, my senior project airplane, which would weigh about 18,000 pounds if it were built, and my DBF airplane, which weighed about 2 pounds empty. I may have had a little advantage writing some codes for that big airplane because I just used the codes I had already written. So calculating your drag and calculating your structural loads and all of that, all the formulas are the same and the process can be the same. It's just a matter of knowing your different limitations. For example, on a remote control airplane, a lot of the time you get a lot more power out of your motor than you would out of an engine on a full-size airplane. So on a remote control airplane, it's perfectly reasonable to have your thrust be twice your weight while you're flying. Whereas on a full-size airplane, unless you're talking about a very, very high-performance fighter aircraft, you wouldn't see that. So it's just, and just being able to go through the process, I think really helped with getting an understanding of how everything went.
I can see that. I guess that would make sense. If I remember correctly, the Wright brothers started with model aircraft too, and then progressed to kites and gliders before they finally made it to airplanes. So that makes a lot of sense.
Yeah, that's actually another good point too, because Design, Build, Fly, we did get some funding from different aerospace companies, and we kind of like to joke that they were giving us that money so that we could get all of our screw ups out of the way before we went to work for them. Because Design, Build, Fly, we jokingly called it Design, Build, Crash sometimes, because each one of these airplanes, we'd probably get 5 or 6 flights out of it if we were lucky before we wound up crashing it, because we were designing to try and win the competition. So we were right at the edge of being able to fly.
Competition will do that to you. Very good. What tools do you find that you use the most? I know my dad used to talk about slide rules back in the day, and that ship's out a long time ago. What tools do you find yourself using the most on your everyday work?
So I've been actually meaning to teach myself how to use a slide rule, but I haven't got around to it yet. The main tool I use in my daily work, I use a lot of MATLAB, which is a data processing tool. It's sort of a coding language, but if you talk to someone who works in computer science, they'll tell you it isn't. But it's a data processing tool that I find really helpful for analyzing large amounts of the large amounts of data that we get. I also do a lot more work in Microsoft products, Word, Excel, PowerPoint, than I thought I would, but that's how we go through and roll out those changes to customers. In college, I did some work with SolidWorks, which is a solid modeling tool, and I know that we use CATIA as well as a solid modeling tool. And then we have a whole host of other more specialized programs that if you're, say, a structural engineer, you might use a finite element modeling tool to figure out how your wings are going to flex while you're flying.
Let me ask this one. I know that one of the things that we leveraged from you extensively back when you used to work at the museum, helping out with our camp programs and on the weekends, was your knowledge of the 3D printers that we were operating back then. I know you mostly work with aircraft that are already built and in service, so I don't know if there's ever issues that come up with replacement parts or if you have to do rapid prototyping, but does 3D printing have a place in the type of work that you're doing, or is that something that's more seen downstream to folks who are designing the aircraft in the first place?
So 3D printing does definitely have a role in the aircraft design process and the current aircraft manufacturing process. I personally don't use 3D printing very much, but I know a lot of people who are on our manufacturing team who do a lot of work with various additive manufacturing processes.
As a matter of fact, one of the speakers we have coming in a couple of weeks, Mark Vanbergen, he actually trained a museum's own restoration shop on how to build parts using a 3D printer. And the Fokker triplane that we put on display last fall includes a few 3D printed elements. We're coming up towards the end of my structured questions for Jake. So if anyone's out there who would like to go ahead and share a question, you can go ahead and unmute your mic and share it with Jake at this time, or you can go ahead and type it in if you prefer on the chat. We'd be delighted to have you join in and ask a few questions. But Jake, while we're waiting for folks to get their questions going, one last one for me. What's the most rewarding part of being an engineer at Lockheed for you?
To me, it's just being able to do work every day that I find really interesting. I am able to go in and look at the problems our customers are having and come up with a good way to solve them. And I just think that that's really great, being able to support everyone and do work that I personally find really interesting. The way I see it, I've pretty much always known I wanted to do some work with airplanes, and now I get paid to work with airplanes, and I love it.
Now, you can't beat it when someone pays you to do something that you really enjoy.
Oh yeah, for sure.
Let me ask, now the aircraft that you have previously worked on to this point, the C-130 and the C-5, they're different in a lot of ways. They're different in size, but they're also different. We talked a little bit about this. The C-5 is only operated by the U.S. Air Force, whereas the C-130, there's all kinds of customers, as you say, who operate them all around the world. Does that create a difference in how you manage those programs and how you communicate with customers?
In terms of communications, yes, it does, because when we're dealing with an international customer, there are different laws in place with what we're allowed to communicate with them. Whereas with the US government customers, the policies are slightly more lenient because we're not sending information out of country. In terms of other things, honestly, it's remarkably difficult to find times to talk with, say, the Royal Australian Air Force, where it's not in the middle of the night here or there. Had a lot more meetings at 6 or 7 p.m. than I thought I would, because I talk with the Australians sometimes.
Those Aussies. Oh, interesting. All right, we've got a question here from Kathy Mertz. What are some factors that determine the number of blades on a propeller?
That's a good question. So part of when you're looking at blading a propeller, what you're looking at is how fast the engine is able to turn it and with what torque they're able to. So if you look at an early C-130, say a C-130A, you'll see that the propellers actually only have 3 blades on them. Whereas if you look at a C-130J, you'll see they have 6 blades on them. And that's because of different changes in the engine, where the engines now have so much more power available that if you only had 3 blades, you would have to accelerate the blades so fast that you might even get some supersonic effects at the edges. Whereas with 6 blades, you turn them slower, but they're able to generate more thrust. So that's a really good question.
Interesting. All right, we've got one from Mike Singer. I'll pass along to you. Can the C5, oh, this is interesting. Can the C5 and or C-130 fly on one engine? If not, what's the minimum number of engines required to fly?
So I have not done the math specifically on one engine. I know that we have flown C-130s on 3 engines before, and if we authorized flight on 3 engines, that would probably mean that we could stand to lose 1 more in flight and still be safe to fly, to have a safety factor. So I'd say probably you could probably push it with 2 engines. I'm not sure if you could actually take off with 2 though.
Yeah, I would imagine it's related to the weight of the aircraft, since these are designed to be cargo planes and also designed to fly a long ways, implying carry a lot of gas. I would imagine there's a really big difference between an almost empty weight and a fully loaded weight.
Oh yeah, there's a massive difference. That picture I showed you of the LM100 when it was upside down at an air show, if there were cargo in that, he would not have been able to do that. That was possible because it was a airplane carrying no cargo, and because it was taking off and landing at the same airport where it was doing the air show, it was probably carrying very little fuel too. So yeah, performance is very different if you are pretty empty.
All right, we've got a question from Mateo Lopez. For high school students who want to become aeronautical engineers, what are some tips that you would recommend for them while they're in high school in terms of extracurricular activities, how to go about college admissions, and things of that nature?
That's a good question. So I was very fortunate at Cal Poly. The California State University system, CSUs, they do not actually, at least when I was applying, oh geez, 8 or 9 years ago now, they did not look at extracurricular activities. They just looked at your GPA and your SATs and your ACT scores. What I would say is, if you're really interested in going into engineering, I would focus on math and science and try and get as much of it out of the way as possible. While I was in high school, I took a few math classes up at College of San Mateo, and that helped me get my calculus out of the way before I started college. And one thing about aeronautical engineering, at least at Cal Poly, is that the 4-year graduation rate is fairly low. Most people take 4.25 or 4.5. But because I was able to get those classes out of the way while I was in high school, it gave me a little leg up on getting finished in 4 years. In terms of extracurricular activities while in high school, I was on the tennis team, and I did Quiz Bowl, both of which I very much enjoyed. And I talked about how I think Quiz Bowl influenced my quick thinking ability, but that's by no means required to go into engineering. I would just focus on keeping your grades good and seeing if you can maybe even get a little bit ahead in math and science.
Interesting. Let me ask a follow-up question here. I know just from experience that Cal Poly San Luis Obispo has a good aeronautical engineering program. Are there any other schools that are really known for that or have an excellent program?
So living here in Georgia, a lot of the people I work with are Georgia Tech grads, which that's one of those things that anyone who's listening to this with their parents are probably cringing as I say, oh yeah, I moved to Georgia. Outside of that, schools in California, I applied to UC Berkeley for their mechanical engineering program, which is
Go Bears.
which is very well respected, and you can do an aeronautical concentration there. I've spoken to many of their engineers at the Design Build Fly competition. Caltech in Southern California is also very well regarded, and Purdue is very well regarded for engineering, as is MIT. Really, a lot of places, just being able to get an aeronautical engineering degree is impressive and will help you get work in the field.
Although I'll say, I mentioned my brother earlier, he decided to get his degree in mechanical engineering because he felt, I think at the time he was going into the career, it wasn't not necessarily as many jobs open in aeronautical engineering, at least not the way there are now, and he felt that would give him more flexibility. But that certainly hasn't held him back. He's worked for the old McDonnell Douglas, he's worked for Northrop, he's worked for Command, and now he's currently working for Boeing. Got a question here from this Jeff Bass fellow. Is Embry Riddle considered to be a good engineering school? I know we've had some students come through from there as well.
Yeah, I've worked with a lot of people who went to Embry Riddle. Down here, it's mainly the Daytona Beach campus that I've worked with, but I very strongly considered Embry Riddle when I was applying for colleges. It was actually, when I narrowed it down, it was between Cal Poly and Embry Riddle. So I think Embry Riddle is a very good school. I do want to mention also that an aeronautical engineering degree isn't really required. I have a good family friend who also works for Boeing right now. He got his bachelor's degree in mathematics. So there's a lot of different ways to approach the field. Yeah.
Oh, interesting. All right, here's another. This is an interesting engineering one. All right, this one is from Araj. Excuse me, Araj. The F-22 does not have winglets, but it doesn't have a high aspect ratio. So why don't we see the F-22 with winglets?
That's a good question. So there's a lot, pretty much any feature you see or don't see on a plane has some reasoning that went into it, and usually a lot of reasons. So one thing is the F-22 was designed to be a stealth airplane. So you want a low radar signature. And if you look at any design stealth airplane, F-22, F-35, F-117, or B-2 are the ones that spring to mind. You don't see a lot of straight vertical surfaces on those because those reflect a lot of radar. Another factor is just the different roles you see. Winglets are great for adding efficiency for airplanes that are designed to fly for a long time and fly at relatively low speeds. When you start going at supersonic speeds, you run into some issues if you have big vertical surfaces in terms of shock waves coming off of your wings intersecting with the surfaces, which can cause some issues when you're going that fast. And if you're trying to turn really hard while going at high speeds, you need to make the winglets really strong, so it would add a lot of weight. That was a good question.
This sounds like a form follows function thing. You don't expect a C5 to either be stealthy or to be supersonic. So what we'll see on a C5 or a C-17 maybe, I know that's not a Lockheed product, but that particular one I know does have winglets, and it's definitely neither stealthy nor supersonic.
Yeah, pretty much any airplane design you see, there's some reason that it looks the way it does, and usually a lot of reasons combined together to look the way it does. As another example, it wasn't really brought up, the C-17 that you mentioned, and the C-5 and the C-130 that I've brought up, they all have high wings, and a lot of that's driven by needing the cargo door to be able to reach the ground. So you have to put the engines way up in the air to avoid them being too low to the ground when you're trying to land.
But yet, the 747 was designed for the same competition as the C-5, and it has a low wing. Or is that the reason it didn't get picked?
I'm not actually sure. That's a really good question. Whenever I've seen a high wing cargo plane, that's a large part of the reasoning that I've heard, and I'm not entirely sure. But if you look at the ground support that a 747 needs to operate for cargo, it needs a lot of different loaders to open and close the doors and push the cargo in, whereas on a C-5 or a C-130 or a C-17, you can drive right up the cargo ramp and be good to go.
All right. Well, we do have time for another question or two. If anyone has an additional question they'd like to share, this is your chance. We'll be saying goodnight to Jake since it's about 10 after 10 out in Kennesaw, Georgia right now. But Jake, let me just ask you this. You've moved from C-5 to C-130. How does it work when you're at one of these major aerospace companies? Do you get to pick which projects that you work on, or do they pick for you?
So generally the way we work right now is we work functionally. So each group, like before I was in operational loads, now I'm in reliability, has people that work across, in this case, our AMMM or aerial mobility and maritime missions. So that's C-5, C-130, and P-3. Each group works all of them, and within the group, it's just a matter of which one you specifically work. Generally, most of our engineers in our group work on C-130 because C-130 has thousands flying, whereas C-5 has 52 flying. So that's a good question. In terms of me picking my project, when I first moved out here, I didn't really know what I would be working on, and I found out it was C-5. But I did still do some work on C-130 while I was there. When I moved out of that group, I knew specifically that I would be working on C-130 just because they already had their C-5 person, and there aren't very many C-5 people.
Understood. We got two more questions. First of all, Sonia, you're out there. I've unmuted your mic. I saw your hand pop up. If you've got a question, please go ahead for us. Nope, Sonia, you're gone. All right, maybe your hand went up by accident. If you have second thoughts about that question, come on back to us. I've got one more from Jacob, and Jacob wants to know if you have a pilot's license, Jake.
I do not have a pilot's license. I know several engineers I work with who do have pilot's licenses, and it's definitely something that would really help your case for working in the field. It just shows that you do know your stuff about airplanes. I personally don't, and that's honestly partially just been a cost thing. Getting a pilot's license can be fairly expensive unless you want to go through the military, and when I have a little bit of spare money, I might go for it. I think it sounds like a good thing to do, but I do not currently.
Does Lockheed have a program to support pilot training for its employees? I know that Boeing had one. That's how my brother ended up with his pilot certificate.
I couldn't say. I haven't really looked for it. I know some people who do have them, and I don't know how they were funded.
Understood. All right, we've got just a few. I don't want to keep you after our 7:15 Pacific time cutoff, and I've got three questions. Everyone's got their last questions here. Tom DeGiorgio's asking, hey, he flew C-5s back in the 70s, and he really liked the Crosswind landing gear. Is that feature still used in the current models or the updated models, or has it been changed at all?
I am honestly not sure. I haven't really done much work with the landing gear. I've mainly been, for C-5, looking at the flight conditions. I do know that the C-5 does have one of the most famously complex landing gear configurations in aviation. I believe at different points to pull up the landing gear, they need to be raised. And so they raise vertically and then swing upwards into the fuselage. And I remember that that was originally designed back because they wanted to operate them off of smaller, less prepared runways. Nowadays, they just use them off of the big runways. So that's not so much of a problem anymore.
All right. All right. Oh, hello, Lindsay. Lindsay is joining us and asks, what factors typically have the most impact on the service life of an aircraft? For example, systems obsolescence versus maintainability versus operating costs.
Hi, Lindsay. Good to see you again. So that's a really good question. It really depends on what you're looking at, what perspective you're looking at it from. In the military, aircraft can keep flying for longer, even if their operational costs get high because they fulfill certain unique roles. For instance, the C-5 has been flying since 1968, I believe, 1967 maybe, with the most recently built ones being in the late 1980s. And yet they're going to keep those airplanes flying until, I believe, the latest projection I've seen was 2040. So because the C-5 fulfills that unique role as a large cargo hauler, it will keep flying as long as the Air Force needs it to. The same thing with the U-2s, which I also saw being stretched midway through the 21st century. In terms of obsolescence for systems, most of the times for avionics systems, we can upgrade them over time. When the C-5s came in and had their engines redone in the last few years, we did upgrade their avionics systems at the time too. And in terms of maintainability and operating costs, the costs do go up with older airplanes, but we do our best to keep the aircraft maintained. And if there's a part that's nearing what we think its service life will be, we usually go in and make sure there's some replacement or repair ready for it.
All right. I've got one last question for you, Jake, and this is coming to us from Nancy. What's your favorite aircraft of all time? And if it's not a Lockheed product, we won't tell anyone.
That's a good question. It is a Lockheed product, actually, as I think about it. It's the P-38 from World War II. Yeah, I think there was a lot of really fascinating engineering work that went into the design of the P-38. For those of you that don't know, it's got a twin tail boom with a really wacky looking tail. There's a lot of just really fascinating design choices that were made in that, and it makes it a very unique looking airplane that I think operates really well. I also like the Beech Starship, even though it never really did much.
The P-38, that was one of the original Kelly Johnson designs, wasn't it?
Yeah, I believe that was actually, I'm actually reading a book right now on the history of Skunk Works, but yeah, the P-38 was actually Kelly Johnson's first design at what would later become the Lockheed Martin Skunk Works.
All right. All right, well, Jake, we've got to the end of the questions. I really appreciate you spending some time with us so late on a sultry southern evening, answering some questions and telling us a little bit more about what you've been doing. Thank you so much for joining us. Everyone out there in our Hangar Talk Hangar, again, thank you for coming tonight. We're really pleased to have so many of you and be able to answer so many of your questions and share this little bit of aviation with you. We'd be delighted to have you join us again. Again, we have Brandon Nadoon joining us next week with his experiences as a high school student pilot. And then we also will have Mark Vanbergen joining us thereafter. Tell us a little bit about his experiences working as an engineer in an entirely different kind of company, a startup working on personal air mobility. There's more information about our upcoming Hiller Hangar Talks, and registration information is available on our website, www.hiller.org. And we will also have updates to Hiller at Home, our upcoming virtual invention lab sessions, and everything else for you while we're continuing forward during our shelter in place. So thank you so much for joining us. Stay safe, stay well, and we'll see you at the next session of the Hiller Hangar Talk.